All right, so we're going to talk about, we're going to start with chapter 2.1. And this chapter is all about functions, how to work with functions, how to graph them, and, all of that good stuff. Solve them, and so on and so forth. We're going to start first with what we call a power function, okay? A power function looks like this. F of x is ax to the n. And, where a and n are non-zero constant real numbers, okay? So when we talk about a power function, remember that exponents can be positive, negative, or a fraction. Okay. Okay, now let's talk a little bit about how we manipulate this stuff. So y equals x squared, that's just y equals x squared, right? So remember that if I have something like this, y equals x to the negative 2, that's the same as 1 over x squared, right? You should be very comfortable going back and forth with these two. And then also remember, rational exponents. So if you have, something like this, 2 to the power of 2 over 3, or better yet, if it's like x to the power of 2 over 3, then that's, the cube root of x squared, and that squared could either be inside or the whole thing to the power of 2. Okay? All right. All right, so let's talk about the case where the exponent is an integer. All right? So suppose you have f is a power function that looks like this. Ax to the n, where n is a positive integer, right? N is a positive integer. That means, 1, 2, 3, 4, and so on, right? Okay. So let's think about this for a minute. Suppose n is even and a is positive. So let's come up with an equation that looks like that. Y equals, okay, a is positive, let's say 2. X to the power of 4 or 2 or so on, right? So that meets the requirement here. The exponent n is even, 2, 4, 6, 8, and a is positive, right? Okay. What happens here when you have something like this, right? If x is whatever value x is, right? Y is going to be a positive number, right? Because you're going to take x to the power of 4, it's going to be positive. Whether x is negative or positive, it's not going to make a difference for both negative x's and positive x's. Y is going to be a positive value. So when you have a function that looks like that, okay, and you graph it, then both ends are going to face up, right? Does that make sense? Yeah. Okay, well, what if n is even again, like x to the 4, but a is negative? What happens then, like negative 2? In that case, both ends will face down. Is that right? Okay. So that's our first case. When you have a power function, even exponent, and then depending on the coefficient, you can figure out if they end up, if they go up or down. But the point is, both ends will either go up or down. Okay? All right, so let's talk a little bit about, if you have a function like this, what is the domain? Is there a value of x that you cannot plug into this function? No. Any value of x works in the function. That's why the domain is negative to positive infinity. Okay? Range, right? When you have 2x to the power of 4, right? Think about your y values. They're only ever going to be positive, right? Can they be 0? Is it possible to plug in a number and get 0? Yes or no? 2x to the 4. Is it possible to plug in a value for x and get 0? Yes. Yeah. So the range then, it could be 0 or any other positive number. That's why the range is 0 to positive infinity. Okay? Whereas if you have negative 2x to the 4, right, then again your y value could be 0, but then you have all of the negative y values. So the domain is all reals, but the range is negative infinity to 0. Okay, so that's when the exponent was even. What if we have an odd exponent? What if n is odd, right? Well, we have two cases. If n is odd, you can either have a positive value for a or a negative value for a. Now, when n is odd, right, one end will be up and the other will be down. Okay? And then you have to think about what happens if the coefficient is positive. So, if the coefficient is positive, think about it. Don't memorize anything. For positive values of x, will this become a positive or negative number? Positive. For negative values of x, negative 1, negative 2, negative 3, will this entire thing be positive or negative? Negative. And then for the other one, it's opposite, right? If you have negative 2x to the power of 3, for positive x values, y value will be negative. For negative y values, for negative x values, y values will be positive. Okay? Domain and range are all reals for these. Okay, so that's that. All right, let's do a couple here. All right, I have half x to the 6. Even exponent, it means both ends will either be facing up or down, right? X, so in this case, they'll all be positive. So now look, we know how to graph y equals x squared, right? Remember when we had y equals x squared? If this is the vertex, if I go over 1 unit horizontally, how much do I go up? 1. And if I go over 2 units horizontally, how much do I go up? 4, right? Because it's the square. Well, here it'll be to the power of 6, right? So if I go over 1 unit, I go up 1 to the 6, disregarding the coefficient. And then if I go over 2 units, I go up 2 to the 6, right? Now, let's do that, but factor in the coefficient as well. Okay, so let's graph and analyze this function. When x is 0, y is 0, I know that. And I know in my mind that both ends of this will be up, right? Right, I'll do that later. So first, when I go over 1 unit horizontally, rather than going up, because there is a half in front, I'm going to go up half, right? Does that make sense? Now, if I go over 2 units, I would normally have gone up 2 to the 6. How much is that? 64. But now, because there is a half in front, I'm going to go up 32 units, right? Okay, I obviously can't put 32 over here, right? I know that when x equals 2, y is going to be 32. So basically, I know that as long as I'm between 1 and 2, my graph isn't going to, like pass that range. So it's super, super narrow. Do you see what I mean? Okay, because only at x equals 2 is it going to hit like 32. All right, so domain, I know before or after I graph. I just see this function and I know what's the domain. Negative to positive infinity. Right. What is the range? 0 to infinity, and it includes 0. X-intercepts, where does it hit the y-axis, the x-axis? At 0. So f of 0 is 0. Y-intercept, 0, 0. So there are 2 ways of writing the same information. I'm doing it in 2 ways just to show you that both are acceptable. End behavior, as x approaches negative infinity, f of x is positive infinity. So for both ends, it's positive infinity. Where is this continuous? It's continuous everywhere, right? So negative infinity to positive infinity. Okay, it's increasing from 0 to infinity and decreasing negative infinity to 0. Okay? Yes. Yeah? No. Okay, negative x to the 5. Before I graph, what's the domain going to be? Is there any value for that you can't plug in for x? No, so the domain is all reals. Okay, so now this is an odd exponent. That means one end will be up, one end will be down, and it'll stretch forever along the y-axis. So the range is also negative to positive infinity. So now, is this going to go up on the right or down on the right?
Down on the right.
Down on the right. Think about it. When the x values are positive and you plug them into this function, is the whole thing going to be negative or positive? Negative. Right? So at 0, it's 0. At 1, it's negative 1. So here it's positive 1. And again, when I go over 2 spaces, I should go down 2 to the power of 5. So again, this is going to be super narrow. Okay? All right, x-intercepts, f of 0 equals 0. Y-intercept, same. Okay, left end behavior. What do you think? Positive or negative? Positive and negative here. It's continuous everywhere. Where is this function increasing? Nowhere. So we just say none. Decreasing. Right. It's decreasing its whole lifespan. All right. Okay. All right. 2x to the minus 2. Oh my goodness, we're doing so well. What happened here? Well, let's write this in better form. 2 over x squared. Let's think about this for a minute. Let's think about the domain. Is there any value of x that you can't plug in here? 0. So x can't be 0. That means everything from negative infinity to 0 is okay, and 0 to infinity. So x can't be 0. That means here, this way. X can't be 0. So here, there is a vertical asymptote. Right? At x equals 0. Okay, values of y. Values of y. Well, there's no x. Yeah, there's no x-intercept. Right. Okay, so let's talk about values of y. If we plug in positive values of x, are my y values going to be positive or negative? Positive. If I plug in negative values of x, are my values going to be positive or negative? Positive, because they're going to be squared. So positive on the left, positive on the right. Is there a value of x that would make this function 0? No. So the y values can't be negative and they can't be 0, but I can get positive y values. Because it can't be 0, y can't be 0, there is also a horizontal asymptote, right, at y equals 0, right? So y can't equal 0. All right, so now we know that it's going to have to follow the asymptote on the horizontal axis and the vertical axis. Okay, so I know that here it has to follow the asymptote and here it's got to follow the asymptote. Same with these. So now let's think about this. When x is 1, how much is y? 2. And when x is negative 1, y is 2. That sort of gives me a good ballpark to do my arc and I'm going to do it this way. We're not doing NASA precision. We're also not going to be completely off either. Okay, so what's the range here? 0 to infinity, open. No x-intercepts, no y-intercepts. Okay, the left end behavior. What do you think? Somebody tell me. Left end behavior. It's going to 0. As x approaches negative infinity, y is leveling off as 0. What about positive infinity? 0 again. Okay, where is it continuous? Well, from negative infinity to 0, 0 to infinity. Where is it increasing? Negative infinity to 0, and it's decreasing 0 to infinity. Moving on from power functions to radical functions. Right? So this is an expression with rational exponents. And like I said before, if you have a rational exponent, you can write it in radical form, right? So if you have x to the power of p over n, this n here, okay, first of all, this whole thing, right, is a power expression. This n is an index. Okay, and when you write it in root form, that n goes inside the root here, index, and then the p is the exponent, right? I know you guys know this. Okay, so let's talk about radical functions. Is it the same if you have a square root versus a cube root? No, right? Okay, so if you have an even index, all right? So for example, f of x equals root x, f of x equals fourth root x. What's the biggest issue that you could have? What's the biggest issue with root x? Right, the biggest issue is that you can never allow the inside, the radicand, to be a negative number, right? Can it be 0? Yeah, it could be 0, but it can't be a negative number. That's why the domain, right, you see the domain is 0 to positive infinity, and so is the range. All right, but if you have an odd root, cube root of x, fifth root of x, then you can have negatives in there, you can have positives in there, you can have 0 in there. So the domain and range are both negative to positive infinity. Okay? All right, so let's take a look at this one. Okay. Now, I'm actually going to do B before I do A. All right, B is a cube root function, right? Cube root that looks like this. Now, take a look here. What does this 3 do? It shifts the graph up. What does the negative do? It's a reflection around the y-axis, around the x-axis. And then here, what about the 5x minus 1? Where is the what's the horizontal shift? To the right, how much? Just 1? 1/5. So you say 5x minus 1 equals 0, x equals 1/5. That's the horizontal shift. Okay? And so we moved up 3 units and over 1/5. Okay. Now, how is this going to look? Is it going to go up on the left or the right? It's going to go up on the left, right? Because it's going to be the reflection of this. Yeah. Since it's negative. Okay. All right. So If you don't have your calculator, if this is not a part of the test where you don't have a calculator, or the quiz rather, by the time we're done with this chapter, you will know how to do this stuff like very, very well. You can, obviously graph on the calculator if you have it, but if you don't, right, you know that it's going to go up on the left and then down on the right. So here it's going to look like this. Okay. Well, yeah, if you don't have your calculator. So let's actually put this on the calculator and I'll show you exactly what I want. Okay, so do you see how it crosses the x-axis here? Let's see where the 0 is. So second calc, 2. Left bound, somewhere here. Right bound, here. Right, and x equals 5.6. Okay? So that's how it'll look. Okay? All right. Now, what's the domain? Negative to positive infinity, and so is the range. X-intercept, we just found it. So f of 5.6 equals 0. Y-intercept. What's the y-intercept? Okay, do you guys know how to find the y-intercept here? The best way is I press trace, and then in trace mode, I hit x equals 0, and it's 4. Same thing, you do trace, and then in the trace mode, if you hit like 0 for x, it'll give you the y-intercept. I'll show you. You would plug in x equals 0. Yeah. Okay, so if you were to plug in x equals 0, f of 0 would be 3 minus cube root of negative 1. That's 3 plus 1, which is 4. Yeah. Okay, end behavior. As x approaches negative infinity, this goes to positive infinity. And here it's negative infinity. Continuous everywhere. Where is it increasing? Is it? Never. Where is it decreasing? Everywhere. All right? Okay, so when I graph this one, okay, so do you see how that looks? Okay? All right, so here's what we're going to do. Menu, hit 5 for trace, 1 for graph trace. Now, in trace mode, I can plug in any x value and it'll give me the y value. So at 0, it's 0. I hit 1, enter, and look, at 1, it's 7.07. You see that? Like, that's one of my favorite things in the world. And then at 2, it's 20. So it's going to be very, very thin here. Yeah. So here it's 0. At 1, we said it was 7, right? And then it goes up like that. So it's going to sort of go like that. Okay? All right. Domain. Tell me domain. Quick, quick, quick. Range. Yes, range. X-intercepts, f of 0 is 0. Same for the y-intercept. Okay. As x approaches negative infinity, there is no limit here, right? Because it doesn't exist on this part. So we just say dne. It does not even exist there, right? And then as x approaches positive infinity, it's infinity. Well, first and foremost, it's a square root. So we know only positive values of x can ever exist here, right? The domain is from 0 to infinity. Like this graph doesn't even exist on the other side of the axis. So since there is physically no graph there, then there is no limit, then there is no like end behavior at negative infinity. We just say does not exist. Okay, it's continuous from 0 to infinity. And it's increasing from 0 to infinity open, and it's never decreasing. Huh? Continuous, we do closed. Increasing, decreasing, open. Yeah. Okay? Because it's also continuous at 0. Okay? Okay, so last but not least, we have to recall how to solve radical functions. I know you do this in algebra 2, and then we're just going to recall here. So here are some steps. Step 1 is isolate the radical expression. Now, if there are 2 radical expressions, it's easier to have one on each side, right? So if 2 radicals, one on each side, it's easier. Step 2, we're going to raise each side of the equation to the power equal to the index of the radical. So if it's a cube root, we do to the power of 3 to the power of 3. Solve for the indicated variable. And then this is the most important check. We have a step. We have to check for extraneous solutions. These are solutions that don't satisfy the original equation. Now, when you go in and you start squaring things, raise everything to the power of 4 and so on. If you started with a square root of x equal to, whatever, right? Remember,
well, our grandmother decided to stop living, so.
Okay.
Come here.
Right. So if you go around squaring things, right? So if you start with like a root x, right? Root x has like very clear-cut conditions where nothing in here can be negative. So if you have a root x, that only exists on half of the x-axis. Now if you go and square things and make the square root go away, now you're saying all those other negatives can exist too, but no, right? So especially when you go and, start raising things to different powers, you are going to end up with extraneous solutions. These are solutions that would originally not have satisfied the equation, but now artificially they do, okay? All right, so let's just do one. So first, isolate the radical. It means we're going to add 3 to both sides here. So we're going to get 2x plus 3 equal to root 28x plus 29. Okay? Raise everything to the power of 2. Okay, and now here, what do we get? 4x squared plus 12x plus 9 equal to 28x plus 29. Okay, sometimes the numbers get a little messy, just stick with it, okay? All right, let's bring everything to the left side now. So 4x squared plus 12x minus 28x is negative 16x minus 20 equal to 0. I can divide everything by 4. So x squared minus 4x minus 5 equals 0. I know. X minus 5, x plus 1 equals 0. So what's x equal to? 5 and negative 1. Okay? All right, so let's check. Right? So here's how we check. So first off, x equals 5. Right? We're going to plug it into either here, the very, very original step, or the step right before you squared. If you go and plug it into the step after you squared, that's all going to work. Okay? All right. So let's plug it into the very first step. So 2 times 5 is this equal to the square root of 28 times 5 plus 29 minus 3? And, well, it turns out it is. Okay? All right. Well, how about x equals minus 1? Is 2 times negative 1 the same as negative 28 plus 29 minus 3? Yes, it is. They both work. Hooray. So the answers are 5 and negative 1. Okay? Now, subtract 8 here. We get 4 equals cube root of x minus 2 squared. Raise it to the power of 3. Raise it to the power of 3. 4 cubed is equal to x minus 2 squared. Take a square root, take a square root. What's x minus 2 equal to? Just 8? Plus or minus 8? So x equals 2 plus or minus 8? Yeah. Yeah.
I got the same answers that you guys.
Okay. So x equals 10 and negative 6. We're going to plug them back in and check, and they're both going to work. Okay? They both do work. Correct. Correct. So if you start with an even root, then it's more necessary to check. All right? Okay. Yeah, the even roots. You're not going to have too many of these anyway. All right. So here you have two radicals. Do you see that? And I like to have one on each side. So let's square these. So I'm going to get x plus 1 equals to 1 plus 2 times the root plus 2x minus 12. Okay? So first of all, look, you have a plus 1 here and a plus 1 there. Those just go away, right? And then eventually when you bring everything over, you're going to have negative x plus 12 equal to this root. Now, here, if there is something that you could divide out, do it here. In this case, there isn't, so we're just going to end up squaring everything. Let's square this. Let's square this. When I square, I'm going to get x squared minus 24x plus 144 equal to 4 times 2x minus 12. Okay? So that's x squared minus 24x plus 144, 8x minus 48. Now bring everything over. So x squared minus 32x plus 192 is equal to 0. Oh my God, how are we going to factor 192 and 32? Huh? How about 24 and 8? Why not? Oh, I'm sorry, Henry. Right? It is satisfying, though. Okay, so now we get x equals 24 and x equals 8. Well, let's see. So x equals 24, right? So we're going to get here the square root of 25. And is that equal to 1 plus the square root of 48 minus 12? Yeah? No?
Yes, it is. No. No, that's
What's 48 minus 12 these days? 6? 36? That's 7. Huh? That's a plus. So that doesn't work. What about x equals 8? So let's see. Root 9, is this equal to 1 plus the square root of, what is it, 8? So 16 minus 12. So is 3 equal to 1 plus, what's 16 minus 12? 4. Square root of 4 is 2. Oh my God, it totally works. So 24, not going to work. 8, it's going to work. Okay? And with that, even with all the interruptions, we got through this. So this will be due Monday, Tuesday. So you can be thankful that you have another day. Graph paper for all the graphs. Yeah?